Hello, so in this video, I'm going to show you how to solve a circuit like this. But before showing you that, I want to briefly, very quickly show you how to transform a non-inverting op-amp into an inverting op-amp. This is wrong, sorry. Into an inverting op-amp and vice versa. This is an inverting op-amp. How do we know? Because the voltage source is connected to the negative pin. And as we see, the feedback loop will always be connected to the negative pin as well. If we want to transform this op-amp over here to a non-inverting one, I would take the feedback loop, put it on the side, change the polarity here so that the voltage source is connected to the positive pin, and I would put the feedback loop over here connected to the negative pin. I can delete this. So this would be a non-inverting op-amp. If I want to transform this back into being an inverting op-amp, I would do exactly the same process, but the other way around. Switch this over here. And for non-inverting op-amp, for inverting op-amps, the voltage source needs to be connected to the negative input or negative pin. So the negative pin would be here, positive pin would be here, and the loop follows the negative pin. Okay, now that we know that and we know how to identify which type of op-amp we're working with, we can solve something like this. Identifying the type of op-amp that we're working with is the first step. So in this case, we are going to solve first this one, and we see that the voltage source is connected to the negative pin, therefore this is an inverting op-amp. So we're going to use this formula right here. This is the formula in action. As we can see, minus the resistor on the feedback loop, minus 2K over here, over the resistor that is the N on the input, over 1K, this one, times the voltage input, the input of voltage, 1 volt over here. This will give us negative 2 volts, and that will be the output. So now this output is being fed into this op-amp, and it's being fed into the positive pin. So what is this? This is a non-inverting op-amp. Therefore, I'm going to use this formula over here, which is the feedback loop resistor, 1K over here, over the ground resistor on the loop, which is this one, 2K over here, plus 1, times the input voltage, which is this. This is the input voltage, the voltage that we're giving to the positive pin in a non-inverting op-amp. And this will be negative 2. So here, this is actually a multiplication, and it will give us negative 3. Now the third one, negative 3 will be the output here. The third one. This output of negative 3 is being fed into this op-amp through the negative pin. So this is an inverting op-amp. We're going to use this formula here. But this op-amp has something interesting to it, which is this thing over here. It has 2 inputs of voltages. How are we going to solve that? We're going to use this formula twice. We're going to do minus RF over Rn times Vn, minus RF over Rn times Vn. Exactly like that. I'm going to show you right now. So first, minus RF over Rn minus 3K over Rn over 1K over here times Vn. Vn is this one that we got over here, times minus 3. And now minus RF over here over Rn over Rn. In this case, this is our input of voltage, so this will be our Rn times the input of voltage, 1 volt over here, equals 7.5. we can see that all of this is correct in this simulation done on multi-sim, where we get exactly the same values. We get minus 2 volts for the first output here, minus 3 volts for the second, and 7.5 volts for the third. So again, just in case you need one more review of this one, we use this formula twice, which means that we do minus RF over Rn times Vn for the first input of voltage, which is this one over here. And then we do minus RF over Rn times the other input, which is this one over here, Vn. And why do these change? These change because in this voltage input, this is the Rn. And in this voltage input, this is the Rn. Hope that helps.